Welcome to my channel where today I'll explore an underappreciated component within the wider context of software design in UML. I'll be delving into the lesser known, yet intriguing topic of, get ready for it, robustness diagrams. Stay tuned as we uncover their purpose, usage, and why they're not as commonly used as other UML diagrams. Robustness diagrams are an integral part of UML, primarily used in the analysis phase of software development. Now, if you're here, you probably know that UML, short for Unified Modeling Language, is a standardized modeling language consisting of an integrated set of diagrams developed to help system and software developers for specifying, visualizing, constructing, and documenting the artifacts of software systems, as well as for business modeling and other non-software systems. I won't say more than that because there's lots of videos on what is UML and all that, so let's continue. Back to robustness diagrams. These serve as a bridge between business requirements and system design, ensuring that the proposed design fulfills specific use cases. Unlike the other 14 UML diagrams, robustness diagrams are semi-formal and focus more on the interaction of different system parts with respect to specific use cases. Now, there are several reasons for the relative infrequency of robustness diagrams use. First, their overlap with other UML diagrams, like sequence and class diagrams, often makes them, well, at least in the eyes of their detractors, redundant. Yeah, I don't think so, but we'll get to that later. Secondly, their specific niche in early development stages and the complexity involved in understanding them adds to their less frequent use. Also, with the evolution of software development methodologies like Agile and DevOps, there's been a shift towards less formal documentation. This, coupled with a lack of robust tool support for robustness diagrams, has further reduced their popularity. Lastly, on why they're not so common, is the project-specific needs often dictate the choice of diagrams, with robustness diagrams sometimes being overlooked due to their specific utility. Before you get to a robustness diagram's utility, you have to mind the gap, as it were, which we referenced earlier. Transitioning from UML use case diagrams to system sequence diagrams is like moving from a broad, idealistic overview to a demanding, detailed blueprint. Use case diagrams are often optimistically simplistic, focusing on what we want to achieve in a high-level abstract manner. They comfortably ignore the complexities of actual system interactions, like a dreamy sketch of a treasure map. In contrast, system sequence diagrams require diving into the nitty-gritty of how things will actually work. This shift demands detailed technical precision, akin to providing exact GPS coordinates for a treasure buried on the sketched island. It's a significant leap from the user-centric abstract world of use cases to the intricate object-level choreography of system sequences, often unveiling a trove of unanticipated complexities, and again, making that leap is the utility of the robustness diagram. Just as an aside here, sometimes software architects, sneaky secret keepers that they are, will be using robustness diagrams, but they won't tell you or show you those as a part of their project. What's the tell? Notice these strange symbols sitting above this sequence diagram. Those are actually components left over from a robustness diagram. Developed in the 1990s as part of UML's evolution, robustness diagrams consist of merely three base components: boundary objects, entity objects, and control objects. They provide a visual representation of system interfaces, data storage, and business logic interaction. All right, so that's really the background I want to lay out here. While robustness diagrams play a crucial role in bridging business requirements with system design, various factors have limited their usage, and in the next video, we'll put the components together and jump the gap to keep the metaphor going. I'll see you then.